Guys, will we start our classes?
Good morning, everyone.
Good morning.
Okay, good morning, all the guests and the attendees.
गुड मॉर्निंग। संस आए हुए हैं, फिर कल जा रहे हैं वो वापस। तो ये जो हमारे यहाँ ना सर 3 बच्चे नॉन एसी बैठे हैं।
So we'll be starting with the
बल्कि मतलब वैसे तो 6 बच्चे होने चाहिए, वो 2 वापस चले गए हैं। एक पहले फीस एक्स्ट्रा जमा किया। Am I audible? तो मेरा रिक्वेस्ट ये है, हेलो,
Yes, sir.
उन्होंने कहा 3 बच्चों के पेरेंट्स ने वहाँ फीस $100 एक्स्ट्रा किया। Am I audible?
So,
तो इधर लोगों को 15-20-25 दिन के लिए जो भी बचे हैं रिजल्ट 31 तक वो ये सी लगवाने के लिए कह रहे थे सर। तो क्या मैंने कहा कि मैं आपको एक बार रिक्वेस्ट करूँ, फिर मुश्ताई से कह दूंगा या जैसे कैसे कहें सर। मैं मेल ड्रॉप कर देता हूँ।
Okay, hello everyone. I am Amol, and on behalf of ISI India, I do hereby welcome all the distinguished speakers, delegates, academicians, students and professionals who are our attendees for today's session. So, I welcome you all for this Vision Quest episode 2, titled How to Maintain Regulatory Standards for Technology when Developing Electric Vehicles, which is co-organized by Automotive Skill Development Council and powered by Plugin Up. As we all know, the world is rapidly shifting towards e-mobility, so there is a need to create a sustainable development of skills of students, academicians, and industry professionals, so as to match the EV industry demand and fulfill the requirement set by the industry. So the Vision Quest is an initiative taken by ISI with awareness, create sustainable development, and make a way forward for it. In Vision Quest, we will be having the guests from Sector Skill Council, stakeholders from automobile industries, academia, research, CEOs and managing directors, vice chancellors, pro-chancellors, industry experts, researchers, leaders. All will be invited for the panel discussion on various topics related to electric mobility. So on today, will be discussing about how to maintain regulatory standards for technology when developing electric vehicles. This Vision Quest is to foster and encourage the learning, inspiration, productive result of engineers and entrepreneurs towards electric mobility. So every year we'll be having 20 episodes conducted which focuses on electric mobility, emerging technologies, market studies, adoption of EV into the market, significance system. So today, in the episode 2 of Fusion Quest, our esteemed guest will be discuss the vehicles, standards, vehicles. The outcomes to the discussion. Now, I would like to introduce ISIE India. We are Asia's biggest e-mobility, motorsports, and skill-based education. We are creating immersive learning experience. We are a National Youth Award winner by Ministry of Youth Affairs, recommended by Ministry of New and Renewable Energy, and endorsed by Niti Aayog Government of India, and associated with 20 plus automotive industries. Imperial Society of Innovative Engineers is also a leading organization for specialization in electric vehicle engineering, through which ISI is having an academia partnership program to fill the gap between industry and academia. We are creating an uniquely placed tech innovation ecosystem which is centered on green mobility and renewable energy. Now, I would like to give you a highlight about the Center of Excellence. So we are proud to announce that ISI India has partnered with Additional Skill Acquisition Program ASAP, Higher Education Department of Kerala Government for two Center of Excellence in Kerala, CSMSS Aurangabad, SSGM Shekhar, National Institute for Micro, Small and Medium Enterprises, NIMSME, and Govardhan Eco Village by ISKCON, wherein we'll be having 20 plus Center of Excellence that will be operational by June 2022. The Center of Excellence is in association with MC Motors India and ANSYS, supported by Society of Manufacturers of Electric Vehicles (SMEV) and certification partner Automotive Skill Development Council (ASDC). The center is aimed to create an ecosystem for skill-based education, research, innovation, and entrepreneurship. Imperial Society of Innovative Engineers is aiming to establish 100 plus centers of excellence for green mobility by 2025 across India. Now, I would like to present a short video giving the details about ISIE India initiatives and the Center of Excellence.
Engineers, ISIE India, being the first organization in India working to encourage green mobility, teaming up with a vast network of experts, has come up with a center of excellence for e-mobility research and skill development, which as a academic innovation, incubation, and skill development, and also research in the field of e-mobility. ISIE India has 9 years of excellence in training graduates and professionals, and we have been awarded as National Youth Award for 2016. Actually, 9 years are of technology and many such awards create a uniquely placed tech innovation ecosystem and center. grab these opportunities, engineering graduates should be trained as per the industry requirement. Imperial Society of Innovative Engineers (ISIE India), being the first organization in India working to encourage green mobility, teaming up with a vast network of experts, has come up with a Center of Excellence for E-Mobility Research and Skill Development, which would act as the epicenter for innovation, incubation, and skill development, and also research in the field of e-mobility. ISA India has 9 years of excellence in training graduates and professionals, and we have been awarded as National Youth Award in 2015-16, Earth Day Network Star Award and Titans of Technology 2021, and many such awards for creating a uniquely placed tech innovation ecosystem centering around e-mobility. The Center of Excellence is a unique facility with machines, workbench, experimental setup, and research setup exclusively designed and developed by ISA India. It consists of 3 labs: EV/HEV Powertrain Research Lab, Battery Prototyping and Testing Lab, Charging Infrastructure Lab. EV/HEV Powertrain is the heart of the vehicle and responsible to deliver the power to the wheels. This lab consists of equipments and setup to help the students and faculties gain better grasp over the motor technology, hybrid vehicle and fuel cell technology. They will be able to design, prototype, test and optimize the powertrain setup. Battery for an electric vehicle is one of the most crucial and expensive components. The participant in this lab will be able to perform various mechanical and electrical tests for the battery or cell, along with the battery pack design and cell sorting. Study about the BMS functionality and design and create a safety circuit for balanced charge and discharge characteristics. Charging infrastructure. As we know, charging being the most major concern in electric vehicles, this lab consists of DC and AC chargers with integrated circuits for V2G charging. This state-of-the-art facility consists of overall charging infrastructure model for 2-wheelers and 4-wheelers. Under this Center of Excellence, we will be offering collaborative BTech, MTech PG diploma with specialization in electric vehicle engineering in association with top universities of India. Certification program with our industrial partners, MG Motors, Hero Electric and many others, and QP and non-QP certification program with Automotive Skill Development Council (ASTC). In our initiative to train future engineers, we have certification partner Automobile Skill Development Council (ASTC), industry partner for skill development MG Dakshata, career opportunities partner Society of Manufacturers of Electric Vehicle (SMVV), technology partner for research and development ANSYS and Hero Electric, and many more. By 2025, ISIEINDIA India with their industry partner and universities will be establishing 100+ centers pan-India and train more than 5 lakh students. Come and join our hands towards a green future ahead.
I hope you all got to know about ISA India initiatives and the Center of Excellence initiative taken by Imperial Society of Innovative Engineers. As we are aiming to establish 100+ centers of excellence in green mobility by 2025 across India. Now, I would like to welcome today's guests and speakers for this Vision Quest episode 2 session. On behalf of ISA India, I would like to welcome Mr. Shrestha Mishra, who is the co-founder of Simple Energy. Welcome to the program, sir. Again, I would like to welcome Mr. Ashish Gupta, who is the Managing Director and CEO of Stephen Electric Private Limited. Welcome to the program. Now, I would like to welcome Professor V.S. Satyanarayana, sir, who is the Vice Chancellor of C.V. Raman Global University. The program, sir. I would like to welcome Professor S.S. Prasad Rao, Director, Sharda University. Welcome to the program, sir. And I would like to welcome Mr. Kavan Rawal, who is the Chief Strategic Sales and Partnership Officer at Earth Energy EV. Welcome to the program, sir. And I would like to welcome Mr. Anish Sharma, who is the New Product Quality Charging Infra Ather Energy. Welcome to the program, sir. I welcome you all to this episode 2 of Vision Quest. Now, I would like to welcome Ms. Khushbu Chanana, who is the founder and CEO of Skill Reporter, to address with a welcome note and moderate the further session. Over to you, ma'am.
Thank you, Amol, for introducing the panelists, and I would like to thank ISI India for taking up this initiative, for creating awareness and inviting me here to be the part of this knowledge session. As we all know, that world is moving towards the electric mobility, and Indian automotive industry is the fifth largest in the world, and envisions to be the third largest by 2030. So fuel intensive mobility will not be sustainable because we are looking at moving towards the electric mobility, and fuels are getting reduced day by day. So in effort to address this, policymakers are developing a mobility option where they believe in the philosophy of shared, connected, and electric, and have projected an ambitious target of achieving 100% electrification by 2030. So when we plan to do something at a massive scale, I believe it becomes very important to bring the role of to have appropriate policy, safety standards, and regulations around that to make it more efficient and effective to work. So today in the episode 2, we are going to talk about the regulatory standards for technology, their benefits, challenges, and a lot more in the EV industry. So, starting with you, Shrestha, since you are into EV development, when we talk about regulations and standardization, according to you, do you find government policies favorable for the industry, and what improvements do you see that can be made in the policy level?
So first of all, good morning to everyone, and thank you for having me over. So as Khushbu was saying, that any technology when comes in needs some regulatory processes, and the process needs to be defined in order to get into production, commercialization, as well as to stabilize the complete market segment. So government is definitely pushing towards the electrification of the existing fleets, existing vehicles that are there in the market, and whichever vehicles would be coming in the market. But at the same time, we have seen incidences like vehicles catching fire that kind of creates distrust among the mind of the customers and the people who want to move towards EV. So right now the government does have certain procedures that they are following, but the majority of the Indian market is flooded with products that are imported from China and sold in India. So that is the major point of concern for companies like us, and in fact from the consumer's perspective as well. Because when you're talking about a country like India, which is so vast and has a temperature ranging of between 0 degrees Celsius to 50 degrees Celsius, and the road conditions, driving conditions, everything is completely different. So you cannot just parachute a product from some other country and start selling in India. So the rules are there, the standards are there, but they need to be more stringent, and the procedure of testing the vehicles that are going into the market needs to be more stringent, is what I feel.
That's absolutely right. Since although the government is working since 2011 on electric mobility, but still India is still in the nascent stage, because we have to achieve a lot more than this, that what we are doing right now. Thank you, Shrestha, for giving your input on this. Moving on to Ashish, since you are into the battery manufacturing, and now because EV is into the market, not at the higher level, but yes, it has started coming out, and people have started buying the EVs. So as the charging infrastructure is being promoted by the government, so what do you think, how government is planning on that? Are there any standards framed, or do you think there should be some standards with respect to the charging connectors and ports should be there?
So Khushbu, I would like to highlight here some standards and some points regarding the battery packs instead. definitely India is looking to be completely electric by 2030 and is one of the fastest growing market. But without standards, this is not possible. So, I mean, at Stephen, we are manufacturing battery packs for all the tier one OEMs for two-wheelers, three-wheelers. We are adhering to IEC 62133 standards for the safety and AIS 156 standards. AIS 156 is a very phenomenal standard. It is inspired from UNR 100 standard. However, I think the gap remains is how closely the standard resembles the actual conditions of operation of vehicles in the Indian market. So just to bring it into context, AIS has some of the tests like charge discharge test, which is done on standard current ratings. But many a times we come across OEMs who are not aware of the peak currents that their motor draws, because the motor capacity is different, passing is different. So many a times we face these issues. So introducing equipment such as slope inclusive chases dynamometer, where we can know the actual current being drawn from the motors, and then accordingly do the testing in the AIS 156 according to those current, and see if the battery design is suitable to that discharge current is very important. Again, then the vibration testing is done at 20 degrees, whereas in real life scenarios we seldom use vehicles at 20 degrees. Most of the time the temperatures exceed 40 degrees in actual usage. And then so these testing should very closely monitor. One more test, very important, fire resistance test, for example, in which you put a flame from outside the battery casing and then see how the battery responds. But what happens when flame is inside the battery, when a cell goes into thermal runaway? Does the battery design prevent it from propagating to other cells and leading to a catastrophic event? That is something which is not being tested at the moment. So anti-propagation tests need to be included. So certain standards need to be upgraded according to the actual usage conditions, and like we do in manufacturing systems. You create a system, you align the stakeholders, so all the EV stakeholders need to be aligned, you roll out, you monitor, and you keep the people accountable for those for meeting those standards. I think this complete process needs to be followed very religiously. If it is, then India has a very bright future, and we can definitely look towards being completely electric by 2030.
Thank you, Ashish. From your views on battery manufacturing and the standards, I feel that there is a lot of scope in the research and development domain on the battery manufacturing and how we can improve on the battery piece part for the EVs. So, Anish, as Ashish was talking about the flames, the testing of the EVs, and because EVs are there into the general public, so but we have also come across that at some places batteries unfortunately didn't work well and it burnt out. So as per the new draft of FAME 2 policy which is out, which mentions about the battery management system, which is which has been made compulsory in the policy for the battery manufacturing. So to what extent do you think it is going to help in further reducing the burning out ratio, and how it can help in improving the batteries mechanism?
Yeah, so at Aether, like I'll talk about Aether, like what we do here and what we do to actually ensure, that kind of misfortunate event doesn't occur with Aether vehicles, right? So we, like Indian government, have defined a standard, that is AIS 156 standard, right? That actually talks about the different regulations and certification that the battery needs to go through to actually qualify, right? And we definitely do that. But apart from that, I feel that the company itself should be very accountable by itself to actually maintain the standard. So we follow even higher stringent standard ourselves internally. We have also gone through EU standards, right? We have actually tried to inculcate them as well, apart from AIS 156. And as well as we have actually also define our own stringent testing procedure. Okay, so our whole battery pack goes through this 4 testing stages, right? By which we actually test the battery and validate it, right? We do functional testing, we do durability testing, we do reliability testing, and then we do a safety testing on top of it. Like I can go deeper and I can talk a lot about all these tests, like what all this test pertain to. But yeah, I think most of the people here at industry know that how these tests are done and why they are important, right? Talking about standards, most people, why actually, I feel that they have not been able to incorporate standards in their design or follow through with the standard in their design, as well as why the product fails, is because people are not very considerate about the timelines when they think about launching their products in the market, right? They don't think about, for the lack of better word, the Murphy's law, right? That anything which can go wrong will go wrong, right? So they have to think about each and every possibility while designing, right? They have to actually define, the complete standard, like deeper specification of the product, as well as they have to actually go through the standards that are already followed in EU and defined by different bodies, organizations who have given out standards on batteries and vehicles, right? And then start the designing process, do a rigorous DFMEA, AFMEA of the product, right? And after they have designed, they should be willing to go to multiple iteration, right, of their prototype, test them out with in different conditions. That, as Ashish was saying, that Indian conditions are very different. We have very different operating ranges. Starting from Delhi to Bangalore, right? In Delhi, there is like very extreme weather. In Bangalore, there is moderate weather, but then if you go to the northeast, then there is like high humidity, right? So different conditions India has, and people definitely need to consider them while designing their battery packs as well as their vehicles, and also the charging stations. Right. Yeah,
that's very right. I think since since you are into the entrepreneurial setup and you are working on the EV development, so as Amol has mentioned in the introduction, that we have students and entrepreneurs also who are attending the session. So what kind of technology, technological aspects you would like to share with our students, and because they are the future. So to the students and entrepreneurs, if they wish to move towards the EV entrepreneurship, what kind of technological aspects you wish to share with them that they should consider?
Yeah, is that question for me?
Yes.
Right. So talking about going into the EV sector, right? First, I'll reiterate what I said, right? You should always think like, first, like do like complete market research. What is happening in the market, right? What is going wrong, right? Define the problem statement. That is the first thing. Define the problem statement very clearly. Then you have to inculcate proactive design thinking, right? You have to not do firefighting. That's the first thing in EV, right? It's actually kind of a pun, right? You don't need to do firefighting. You have to do proactive design. You have to put check marks beforehand so that things don't go wrong in the field. That gives a very bad impression to the customer. It destabilizes the market. People are less trusting on the overall EV product market, right? And obviously you have to also think about investing a lot on testing equipments and stuff for rigorous testing. People don't generally consider that when they are starting out. I know a lot of companies, right, who have started out with a very small team. They don't have a full-fledged R&D department. They don't have a full-fledged testing labs, right? And they put out their product in the market. That should never be done. There should be a consideration of investing, and obviously that demands a very high investment. Creating a big team, investing in equipments, testing setups, right? And then after that, you have to also think about conforming to the standard. Think about homologation, and so thinking about homologation, we have thankfully a lot of labs, certified labs available here at India, where you can go to and do pre-homologation certifications. There are a lot of experts which can help you out. Don't shy away from talking to experts. Don't shy away from sharing your problem, getting them rectified. If proper rigorous testing has not been done, don't put out your product in the market. Go through stringent validation plans to validate your product beforehand, and post that, or you should definitely have an process to actually get data from the field, acquire data from the field, be very hawkish to actually monitor data in the field and pay very close attention to the customer feedback, and based on that implement solutions as soon as possible, but not before testing them out. Yeah.
Thank you, Anish. And you said very right that we should learn from the experts and the experienced people when we have to work on something. So moving on to you, Kavan. Since you deal in commercial EVs, and most importantly, I would like you to put some light on the need of standardization and regulations in case of safety and security from the EV perspective, which includes the personal, product, and charging infrastructure as well. Because
yeah. So first of all, as Shrestha sir told, that there are a lot of companies in EV market. Those have bring their products, but the problem is the vehicles are not being treated as a vehicle. They are being treated as an FMCG, good, which is just dumped in the market. There is no concern about the safety. There is no service regulations. There is no nothing. So the need is here to first acknowledge EVs as a product, as a vehicle, and then you can think about getting it into the market. Coming to the safety point of view, as we know that batteries are most important and critical component of the vehicle. So first and foremost thing is how you are dealing with this battery fire issues, or how you are designing the battery. If we talk about portable batteries, the main concern comes when we look at the design. So we see there are the quality of material which is used to make the casing. It is very thin. So as soon as you have an impact on the battery, there are chances that it is directly going to impact your cells, and also the nickel which is being used to join the cells. So this can create shorting. Second thing is, when we are giving portable batteries to the customer, we are not actually guiding them on how to use them. We are not making them aware about the dangers that are there in having a portable battery. So before going to anything, I feel that customers should be educated, your service staff should be educated, and even the person who are selling these vehicles should be educated, so that we can avoid as much incidents as possible. One of the way to do this is we can incorporate shock sensors. Suppose your battery gets hit from any direction, or customer by mistakenly dropped it, so the supply to the output should get cut off. Second thing is, this is just for portable batteries. Coming to the fixed batteries, what we can do is we can use active cooling systems. Although if you have proper BMS, which is cutting off the battery when temperature reaches a certain level, you won't need much of a cooling system because it will degenerate the performance. But anyhow, it is necessary to give certain cooling mechanism if you are having a higher AH battery pack. Next comes the alerts. So what you can do is, if your battery rises beyond a certain temperature, what you can do is you can give an audio or visual alarm. So this is possible only in case, suppose you have a communication between your battery and your display and other auxiliary systems. in Chinese or in imported vehicles, this is not a thing. You cannot do it. So what we need to also do is, if suppose we are dumping these low-speed vehicles into the market, we should make some regulations about it, that how these vehicles are dumped and what safety protocols are being followed in these vehicles. Since in last few months, what we have seen, these incidents are related to mostly the unregistered vehicles. So yeah, these are some points that I like to cover.
Thank you, and thank you, Pawan. It was really insightful, and I believe that if someone comes to you and wishes to learn, it will be an learning experience for them to learn from you.
Definitely.
But, because on ground, when we work on ground, we know the real, challenges and obstacles and the favorable conditions which we go through, rather than the document. That's very right. Satyanarayan sir, I would like to come to you, as you come with a vast experience in research, policy, energy sector, as well as technology. And as we see in National Electric Mobility Mission Plan, local manufacturers are being promoted in this ecosystem. So I would like to I would like you to share your views on what are the obstacles and challenges are there in maintaining regulatory standards for technology in context to development of EVs. Because as we were talking to the Anish, Kavan, Ashish and Shrestha. So there should be regulations, there should be standards, but since we are imbibing local manufacturers as well, so what kind of obstacles and challenges we are going to face?
Thank you, Ms. Kusum, and thanks for ISIEINDIA for having me here. Am I audible?
Yes, yes.
Yeah. I think it's my pleasure to be participating here and learning from industry experts and entrepreneurs. Yeah, I mean, the key point I want to convey here is, yes, I have some experience working in industry, academics, R&D and policy planning. And as all, I think Mr. Anish, Mr. Ashish, Mr. Kaval, all of them have already mentioned. You see, first of all, to do anything, we need to have a systems overview or design thinking as a mandatory requirement. Unfortunately, I mean, it cannot suddenly come into an MSME or a big company. It has to come in through education. And the education has to be linked to hands-on activities and not reading. I cannot know about, I mean, swimming or driving a car or even say, I mean, an aircraft, or piloting an aircraft, having never done that, only read some theory. So I think it's very critical that, I mean, these standards have to be well established. It has to be brought in from education. And just for example, I want, even before I move into mobility space, you see, the enablers in terms of materials, in terms of wires and cable, in terms of even plug points. Today we don't, I mean, we supposed to have set up a standard, but even now you buy a TV, a fridge, an air conditioner or whatever, or even a fan, many times even international company points do not flick into the plug point. I mean, here we are talking of multiple levels of charging. The type of current and voltages involved are mind-boggling, and the wire standards are not even well defined. I mean, you have the designing the wire for optimum utilization. I mean, we don't even have that concept. And as all of them mentioned, most of the standards are being blindly adapted from the developed world, where they do not have the type of 6 climatic extremes or variations that this country has. So therefore, whether it is the encapsulation of the wire, again, right from there, and of course then the dimensions of the wire and the current carrying capability. So many standards need to be defined and enforced, as I said, starting from the plug point. I mean, anyway, our houses are not designed for the high-speed chargings that are supposed to be happening for electrical mobility. Therefore, whole remodeling has to happen, or other additional electronics has to come in. So therefore, I think it's a huge challenge now saying we are going to have Atmanirbharta in electrical mobility, as already all of them have mentioned, whether it is the BMS, whether it is the battery, whether it is the materials, whether it is the electronics, everything is imported and it is still knockdown kit assembly at the most. Or some people have some decent electronic and embedded system capability to better manage their system. But then, as we said, so it's for system thinking, and then again, therefore, it has to have inbuilt provision of design for manufacturability, design for yield, design for, now we are moving into the era of sustainability and circular economy. So design for circularity, design for sustainability, all of them have to be built in, and this has to come through education. And therefore, I think there's a huge need for this education, and therefore the standards that are being defined, because if they were very well optimized for Indian condition, it is again in India, I could be driving in Kanyakumari and tomorrow I might be driving in Leh, Ladakh and Kashmir. So it cannot be, as we said, doing the same thing as I am doing in say US or Europe or even say Japan. Australia also has similar extreme, it's a huge temperature variation time. So these are huge challenges, and therefore I believe defining the standards, we have not done the basic homework. Defining basic inputs on saying, having a system thinking or a design thinking overview, a multidisciplinary approach, as they rightly all our earlier younger entrepreneurs mentioned. See, they have very small teams, and inherently there is no education even of looking at standards. Like today, we have to be now defining the standards. We need to take the lead, work together as a team, and not look at undermining each other or immediate competition, but look at a long-term strategy of developing product, process, solution, and see that how do we work together on even defining standards and because India is one of, I think, the most, rugged country which would need all forms of extremes of capabilities, which is not needed in most other countries. And therefore, when anything, whether it is medical, electronics, mobility, and especially e-mobility, with the whole world looking at sustainability, all of them with Modified will also, everywhere we are going to use electrical gadgets, wiring, charging in various shapes and sizes. So it's a very, very important area that we are having this discussion. And very sorry to say, and the worst part, all of them for the ecosystem to truly exist in every other part of the world. I'm not even going to developed world. You take the Nordic countries, you take Israel, Ireland, Taiwan, Korea, Singapore, new countries which have come in more recent days. See, the local university, the local, startups, they work together, their products are developed, and then it becomes, acquired by multinational, or they go global, and the ecosystem grows there. And here, if you are simply going to import, we will, and with the education system having no clue what is coming into or what is coming into the market, I think maintaining, because it's not just a product. Again, as we said, it's a life cycle, maintaining of that. Because maintenance of the vehicle is at all the fire issues that we are doing, because first of all, it was not designed for India. Next, the maintenance cycle. And as also somebody else mentioned, the electronics to manage the current limits, the peak currents or optimum loads, or even say giving an appropriate warning to say maybe you need to slow down or maybe stop, whatever, all of that has to be by design built in. Today, everything, the amount of complexity and domains involved, and there is no such thought process coming in. Therefore, I don't want to be looking like being skeptic, but we will be able to innovate. But for this innovation to happen, the industry, the academics, the government policy people all have to start working together, have multiple brainstormings and share this information freely and move forward. I just want to add one example. Like say I was in Japan, we were doing some domain called vacuum nanoelectronics, and carbon nanotube had just come, 91. I was there in 91 setting up startup company in a domain called vacuum nanoelectronics, where maybe next generation terahertz devices to X-rays which can be held in a battery, like a pen, X-ray source, or say medical instrumentation, bulk equipments can be now collapsible and taken care, something like those technology. For that, so they created a roadmap of working together. Everybody worked without barrier, saying anybody interested can come in. All of them work together even in a common R&D lab. But then every industry took out whatever was even an IP created there and made their own products beyond that. So we don't see any such effort in any domain. I mean, whether it, because again, sorry to repeat this, see, semiconductor is a basic enabler. The amount of technology, that large area, flexible electronics, and as also somebody mentioned, material science is going to enable in this domain. We don't teach material science. Electrical engineering is being closed in most of the universities. Now, therefore, where do you now even create the human resource? They are going to be looking at it in assignment, product, process, and skilling activity to be innovating or readily available to small, young entrepreneurs to be leveraging them. As I said, the ecosystem that could happen in Ireland, Israel, Taiwan, Korea, Singapore, because they don't have shortage of people. I mean, Taiwan, Ireland, they're so small, but cutting edge products happen. Whole of the big MNCs go and across domain get technology from them. So it's a very huge challenge when we are talking of standards and academics, industry, especially startups, all working together. But as a university, all I can say is we are trying to address all of this as a first step, saying any student who comes into any program, whether it's engineering, management, sciences, social science, everybody in the very first portion of their academics have to study a course in design thinking, has to do a project-based activity or a case study leveraging this knowledge of design thinking to understand that right from basic communication to physics, chemistry, maths, to depending on the domain, whether it's medical, electronics, electrical, all of them have to come together to make a product process solution. And even in their assignments, we are making a project-based assignment, we are saying making students to look at products in the market, understanding specification, even to say, specify specification for design is a key aspect. Most even PhDs today will say, I have developed a product, it works at 10 volt. Working at 10 volt means nothing. Whether it's 10 volt and 1 microampere, or whether it's 10 volt and 100 microampere. Or I might do a vacuum nanoelectronic device which works at 20 kilovolts. But then the current I am going to use is microampere and the wattage is in microwatts. So, I mean, saying the two together and the wattage is a basic school physics. But then most people don't know, even after doing PhD, they would say, I'm doing, energy efficiency issues, but only talk of voltage or current by itself, it means nothing. So it has to start from education and huge amount of advocacy both to entrepreneurs on this process and existing standards adapting to India. Again, sorry to say, sound skeptical. Say, for example, green ratings, we have Griha ratings in India, LEED and all that exists. But then it still doesn't fully conform to the Indian 6 zones clearly. So now automotive electrical mobility is newly evolving. So when you talk of standards, it's a very, very challenging area. And therefore, I think standards, whatever even adapted as of now, whether you're talking of AIS, BIS, IEEE, IEC, all of them are there, but then there needs to be a lot of evolution. We need to be doing it proactively, and it cannot happen as so far all of Indian activity is happening without the academics. It's in spite of the academics, India has become a 2.5 trillion economy, but if it has to become 5 or 10 trillion, the academics have to be an integral part for accelerated, because knowledge life cycles are reduced, products life cycles are even shorter. And so all of them have to seamlessly work for an accelerated delivery, and starting with understanding current standards and also excessive testing, assessments, both simulation based and accelerated testing to real life product activity. I'm just concluding with one point. Sorry, I think I've taken longer time. For example, we did say, I worked with a couple of startups, and one of the startups they worked on the second life battery for 3-wheelers. And also now we have a complete company for even extraction of waste materials from lithium. The factory is already ready in Noida region. And so, and the same while working on the second life to optimize the peak load delivery and for a 2-wheeler. So we looked at various products, various in the market. We even looked at their BMS and indirectly collected data while the cyclist, the rickshaw puller was working across Delhi cities and saying how is it vary and what temperature, again across seasons, to understand the current and load requirement. And from that we defined a modified second life battery with half the cost of the original, but can deliver the same quality and sustained power for each charging over a larger time. So I think standards are the byline or basis under which we all need to design and do development. And for that to happen, we need to clearly start studying the existing standards, do excessive experiments hands-on where students, colleges, universities can do more affordable R&D for the startups, and start developing ahead of the curve. And otherwise, if we are only going to be doing Me Too products, we will nowhere be there, and we will have more accidents and more danger, but we will be the maximum utilizer of these products, and again, therefore, again, having damages more than benefit. So I would want to just thank you for giving me hope. Sorry for a longer discourse, but
no, sir, it was really an informative.
We just need to look at standard. I'm happy that say you're bringing on the skilling platform and talking about this. I'll add more future if and when needed, but would be happy to also work with any of the entrepreneurs here. And thanks again. Thank you. Yeah.
It was really nice to listen to you, sir. Your viewpoints are really helpful and relevant in terms of the standardization on the EV manufacturing. So, sir, adding on to your point that it should start at the education level, since EV, electric mobility, this ecosystem itself is at the nascent stage. So, and universities are now coming up with the courses in the electric vehicle manufacturing and electric mobility related issues. So, I also believe that it should start at the education level, where students and professors are also, equipped
with the entrepreneurs and industries.
Yes,
simultaneously.
Yes, absolutely. Yes. So, students and professors should also be equipped with the changes happening in the ecosystem and what policies are there, what regulations are being followed, how they should work. They should also get the industry exposure as well with the startups, with the entrepreneurs to get the hands-on experience on this. I completely agree with you, sir. So since we have Professor Rao from Jharda University here, and universities play a very big role in the academia part. So, sir, I would like to know your views on the like what best possible contribution from the universities can make to the EV ecosystem in context to the technological advancement.
Yeah, first of all, Kushbu, thank you very much for providing a wonderful opportunity. I congratulate the Vision Quest for organizing such a wonderful event, connecting both academicians like Professor Satyanarayana Rao and also the industry professionals here. Very, very happy to be part of this great Gyan sharing session. Electricity and hydrogen will be the key energy vectors needed in heavy duty or low emission, zero emission or low emission electric vehicles. That is the order of the day now. The government has started supporting the electric vehicles for the last 10-15 years. There is so much research is going to happen, even it is happening. But suddenly people started using the electric vehicles and introducing in a very, very big way, and not taking proper care at the technology level, particularly the batteries. Recently, several incidents are happening, and that has been reported to the government of India also. Even the Central Minister Nitin Gadkari ji also has come into the picture and also shared his observations. Before that, I would like to say one more thing, that the vehicles with internal combustion engines regulations will need to ensure their safe use, because safety is very important. Some of the speakers is mentioning that, like an FMCG, this has been brought to the market and people started using. One should understand the technology element, and one should be very, very careful in handling these equipment, particularly these kind of vehicles, electric vehicles. And one more speaker is saying that, at the 20 degrees Celsius, it is tested. But now it is almost 45, 50 degrees Celsius, the temperatures now recorded. So they should test properly and take precautions properly, then introduce it in the market. We can avoid a lot of fatal accidents had there been proper care taken care of. And establishing technical regulations and standards is a crucial step when introducing new low or zero emission electric vehicle technologies. These are important prerequisites for developing safe and reliable vehicles for distributing the energy for the vehicles and ultimately for their capacity to meet the environmental policy objectives. Significant work in this area has already been done. There is no doubt about it. But the framework of the the international standards organizations, ISO, and other United Nations standard organizations like that, we need to comply with the rules and regulations. And one more, recently a committee constituted to probe and investigating the recent electric vehicles fires found that issues with battery cells are designed in nearly all of the electric two-wheelers fire incidents in the country. The committee was constituted last month in the wake of EV fires and battery blasts in e-scooters belonging to Okinawa Autotech, Boom Motor, Pure EV, Jitendra EV, and Ola Electric also. The experts have found that defects in battery cells as well as the battery design in nearly all EV fires, including the deadly battery explosion in Telangana. News agency IANS reported, quoting sources close to the development. And sources said that the experts would now work individually with EV manufacturers to resolve the respective battery issues in their vehicles. And one more important observation, the government is actually encouraging and promoting the electric vehicles so that we can actually meet the global green standards. There is no doubt about it. But we need not be in a hurry to introduce these vehicles and invite this kind of accidents and problems. So the EV vehicles, actually, I think Ola already has called back around 1,440 vehicles and started revisiting and finding out the reasons for these kind of explosions. So the standards are out, but there more tests should be conducted and more samples should be taken into consideration, and then go it on a larger scale. Because how Professor Sachinandan sir is saying that there are so many research organizations, startups are doing. After making the prototype, it has to be tested and tested at every stage of temperature. Then it should be introduced in the market. Because people in a hurry, one is a cheap fuel, and the second one is comfort. Third one is, of course, investment is high, and it should be brought to the affordable prices. So these are my observations. Over to you.
Thank you, sir, for such great insights. So there is a lot we can discuss on this topic, and because electric mobility is taking space in our lives at a very fast pace. So there is a lot more to speak about, and there is a lot more we can learn from each other. But moving, since we are towards the end of the session, I would like to ask all the esteemed speakers one question, which is related to the social impact of electric mobility. Since 23 states have come up with their state policy, so I would like to ask all of you to put some light on this. That are these policies which have been drafted by states and by the central government as well, are they socially inclined? How they are looking forward to the impact on environment from the batteries that are being manufactured, the chemicals that are being going to used in the EV manufacturing? Can we start with Sachinandan sir?
Yeah, I think I would want to add that it's a step in the right direction, but we have a long way to go. As I said, even the big companies in India today only give lip service to issues like sustainability, circular economy. But then these are, by design, have to come at the system level itself in design consideration. They cannot be added late into the process. And therefore, all the new norms and regulation are great. It's a first step, but it cannot be the be all and end all. And we seriously need to go beyond that. And only then, because we cannot later be regretting, as you said, creating boxes for danger. I mean, like death boxes for people to be riding. And therefore, I think there's a lot more to be done. And again, especially if you're only going to be dependent on imported materials, imported products, imported electronics, then see, it will be impossible for us to deliver any standard. It has to happen here, and therefore it calls a lot of development, but it also means wonderful opportunity of trillions of dollars, because each of the material, each of the electronics, each of the software capability has again application in diverse domains. So it's a unique opportunity for us to leapfrog, but then we don't have, the moment government norms come, every industry, academics, all of them have to start working proactively, not waiting for somebody to give a direction, but start working together to see how to be leapfrog and move forward. Truly, opportunities are unlimited.
That's right. Thank you, sir. Anish, Kavan, would you like to add a few points on how the EV manufacturing is going to impact the environment as we are moving towards the, global warming is rising, and so how it is going to impact the environment?
Right. So, as Satyanaran said, that we are importing, right? And one of the major stuff that we are importing, right, one major component in EV manufacturing, which no one is doing here in India, is the battery cells, right? We do create battery packs here in India, but we don't have anyone manufacturing the battery cells itself. The battery cells itself are very toxic, as we were talking about environmental factor as well, the responsibility of companies, how they tackle this factor. When the cell battery life cycle has gone through, right? Generally, companies give battery life cycle as 3 years, right? After 3 years, what happens to those cells? As they are very highly toxic, right? What people are doing to actually minimize the impact on the environment, right? A lot of companies, and I have opportunity to work with some of the companies, someone was also mentioning, they are companies who battery second life, right? Cell second life, and also recycling, right? So one of the company that I know of, they basically what they're doing is they are getting this batteries. After 3 years, the battery is not completely dead, by the way, right? So the battery has degraded, but it's not dead. So what they do is they take these batteries and they repurpose it. They make a inverter out of them, very cheap inverters, which they can actually sell very cheaply in village areas where the children, right, they can get battery backup late at night, where the people who operate in farms, they get electricity. So they are doing something good, right? They're actually trying to repurpose this battery. This battery can go on for like 2 more years. There are companies who are working to create DMS, which actually gathers all the data and based on battery data, they decide the cell life cycle, they decide how much the cell has degraded, and based on that, they repurpose it according to the degradation. Also, there are companies who do recycle the cells, but the number of them are very small, and the scale that they are doing it at is very small. So what government needs to do here is first
I'm really sorry, I would like to interrupt here. All the guests are requested to please mute yourself. There is a lot of disturbance happening around. Thank you. Anish, please, thank you. Please continue.
Right. So as I was saying, the government what the government needs to do is they need to incentivize and actually push for cleaner cell manufacturing technologies that obviously has been happening around the world. In India, right? They need to make the companies who do manufacture battery packs are responsible for the disposal of the cells as well. And as well as they need to incentivize this kind of recycling and repurposing companies and startups to actually do their their operations at a very larger scale, where they can consume all the batteries which are coming in, all the battery cells which are coming in from outside, and so that the overall impact in the environment is very low. Yeah, over to you.
Thank you, Anish. Ashish, would you like to add on to it?
Yes, I would like to add to it. Like Professor Rao sir said that they quoted that the news agency said that this issue was with the battery design. All those vehicles had passed AIS 156 or ARAI testing. So after stringent tests, only they have come on road. So these policies need to be defined, wherein a tested product, like whom to be held accountable for that? Is that the testing was not done, or maybe the product was faulty? So it's a very big discrepancy here, where it's not clear to anyone what happened. Did the product bypass the testing? And again, so I would like to say that so it's more of a mindset change which is required in the industry today, where we personally, every stakeholder in the industry, be it the user, be it the manufacturer, everyone needs to align with the mindset that we need to produce quality products that meet certain standards, and should not look into ways into bypassing those anyhow. So, and I think education, like Professor Satyanarayan sir said, education plays a major role here. So right from education, the upcoming engineers need to have that automotive mindset, which is following the standards in and out. I think you're on mute, Kushbu.
Sorry. I completely agree with you, Ashish, that we need to make some changes at the education level itself, so that students get the thinkability to think and be socially inclined, so that we can create something which is, more environment friendly. That's really right. I think we are good. Shrestha, Kavan, would you like to add on some points, and so that we can conclude?
Yeah, I would just like to add one more point. So there is one more technology that can be aligned with EVs. That is V2G, the vehicle to grid technology. And although it is at a nascent stage and we are not incorporating much this technology into the EVs, but as the number of electric vehicles will increase, and as the vehicles in heavy segment like LCVs, your trucks, your buses, as the number of these vehicles will increase, your load capacity is needed to be increased at the generating stations. At the same time, these vehicles are not always going to be in use. Like at night time, they are going to be parked. So there is a way that this power from these battery packs can also be supplied back to the grid and take the load of the power stations that are always at a stress. So I see that V2G is a thing that should be focused upon as we move forward, when number of vehicles on the street will increase. And other thing is that we should also incorporate renewable energy for charging infrastructure. Although the amount of efficiency from the solar panels is not that great, but it can also contribute to charging solutions. So yeah, that's the point that I want to add. Thank you so much.
Thank you, Kavan, for the insights about the technology. Professor Shrestha, yes, I think Shrestha would.
Yeah, true. So speaking at the last, you don't have a lot of points left to cover, right? So everybody covered the majority of the points, and as everybody would agree that India is at a nascent stage, but the technology needs to be developed in-house in India in order to compete with the global competitors that are coming up. And importing something from some other country and selling it in India is not a solution. So in longer run, you would have to develop things in India in order to sustain and develop the complete market. So definitely that is there, and all the technologies, there are multiple technologies that can be explored. So it's again a very new industry. Mechanical side of it has been evolving over a period of 100-120 years, but the electronic side has a huge scope of development: fast charging, battery technology, vehicle to grid, vehicle to vehicle. All those technologies are definitely there that need to be explored and worked upon.
That's right. Professor Rao, I think research and development part you would be able to speak on that a lot because I think research and development field is very much required in the EV domain right now. So you are on mute. Please unmute yourself.
One more important observation here nowadays happening because of the advent of the electric vehicles and the development of hydrogen also. There are a good number of students now moving to do electrical engineering. So it's a wonderful opportunity combining electric vehicles and also the IT, artificial intelligence, etc. in these kind of the programs are attracting good number of students to rejoin this branch of engineering. And one more development, there are about 950 universities, more than 45,000 colleges. They are now educating so many students. And I appreciate the efforts put in by Vision Quest, setting up centers of excellence. Please extend this kind of facility because every academic institute is looking for collaboration with industries, and particularly the startups, the venture capitalists, and also the people who have very innovative ideas to come and start something. This ecosystem is going to expand, and the government also is encouraging, and industry is also coming forward. I'm sure there are a lot of opportunities for everyone. But only thing, as our co-speakers are saying, we should not be in a hurry. We should take enough time to test and then launch the product in the market, so that we can establish sustainable model, sustainable growth of these kind of vehicles. That's what I wanted to convey.
Satyanarayan sir, you wanted to answer?
Half a second. I think we have mentioned all the points. The only thing maybe we just maybe did not mention, but because it's the cyber security aspect of vehicle to grid or grid to grid or vehicle to vehicle, or even say wireless charging. Because energy harvesting, scavenging is also something happening in a very large scale as possibilities of the future. Not just connected, but even all these are options, and along with that, the cyber security issue. So these also need to be integrated part of even the standards. It's not just for communication, but even in the charging process, and because it could be both in terms of security, safety of the vehicle with this, say, integrated structural health monitoring or prognostic monitoring aspect, or damage that could be caused externally. So these are also some parameters I think we need to talk about in the inherent standard or overall structure. And many times, say, for example, even the whole Indian energy roadmap of say 2030 or 24, I don't see energy harvesting and scavenging even a word mentioned. So whereas here in the road, this is also a key enabler, and similarly security aspects. So I think there are many points, but as I said, instead of blaming anybody, let us proactively work and take it as an opportunity, and it's a huge opportunity. And I think above all, I want to say we, the academics, have to give the benefit, the credit and the confidence to whether it's an MSME or a startup or a company to believe in us and comes. No point blaming everybody, nobody comes to us. If everybody has their plate full, they have no time for idiots. So therefore, if we cannot proactively create platform, processes, solutions, and say we are willing to work with you, nobody will come. And the new education policy gives that opportunity. I think we academics have to seriously leapfrog or pole vault and come forward to the support of Indian industry, entrepreneurs, and even the government in policy planning. And this, if we do not do, we are doing a huge disservice to the nation. Thank you very much.
Thank you, sir. Thank you so much for your useful insights and thoughts. I think we are good. I would like to over it to Amol to conclude the session.
Yeah, thank you, ma'am. All the guests, actually, there is one question in the chat box. It says, is it possible to have a separate set of standards as per the driving cycles? For example, a vehicle expected to fly in a metropolitan city like Mumbai, so need to have a high grade abilities, typically 20%. So with this, it may be possible to make specific design patterns with respect to the required driving cycles. This might be lead to cost-effective design. Can you please comment on this?
I mean, I just want to add that, say, today electronics can enable anything. You can easily switch, just like you have automatic gear cars. In principle, in electronics, you can say which is the type of environment you're doing, and you could use electronics. That's the easiest way. But again, even technologically, also vehicles can be designed for optimized cost for intercity, or I mean, core of the city working things. So depending on application, also something can be done for optimized. But otherwise, electronics can also do. So there, I mean, I'm sure the entrepreneurs will be in a better position to answer.
Yeah, to answer to that from a commercial perspective, I would say, because in a country like India, where government advises has the regulations that only 2 people can ride a vehicle. So when you're talking about Indian conditions, it's very difficult, because they're in our college days as well, that we have also gone 3 people on a vehicle, 4 people on a vehicle as well. So that is something that cannot be considered while designing the vehicle. That is a very different or very difficult part that you need to take into consideration. But yeah, when you're designing the vehicle, so you can keep these things into consideration, the worst case scenarios and the best case scenarios, and design the vehicle according to the market segment that you're targeting. For example, if you're targeting for, let's say, a B2B vehicle, it needs to be designed in a way that it can carry huge loads. Apart from that, if you're talking about a high-speed vehicle, it should be designed in a way that it can go to a top speed of 100 or 50 or whatever kilometer per hour you're targeting at. So all those things need to be taken into consideration while designing. So that's everybody said that you need to have a clear problem statement that you want to solve for, and then only you can go ahead with designing, developing, and definitely the most important part, testing, validating, before putting it out in the market.
That's right. Thank you, Shrestha. Thank you, Satyanarayan sir, for commenting on that question. Amol, I think over to you. We can conclude the session.
Yeah, thank you, ma'am. And thank you, everyone present here. I want to express my sincere appreciation to all of you for your inspiring words and depth of understanding and ability to present the topic that we have discussed in such an interesting way. I hope all the participants and the attendees have been enriched by this session. I would also like to thank all the participants, because without them this session wouldn't be possible. So I would like to thank all of them. I would like to express my sincere thanks to Mr. Shest Mishra, Mr. Ashish Gupta, Professor B.S. Satyanarayana, Professor S.S. Prasad Rao, Mr. Kavan Raval, and Mr. Anish Sharma. And I would like to express my special thanks to Ms. Khushbu for moderating the entire event. We hope that now you are all aware about the required roadmap for the safety, regulations, technology advancement in the EV domain and the ecosystem. So to bridge the gap between industry and academia and bring this change, as we have already discussed about this regulation part and the safety part. So to bring this change into the academia and industry part, we are looking forward to finding possible synergies for the collaborations with you. So thank you all for joining.
Thank you, everyone. Thank you.
Thanks once again for having me. It was nice listening to all the panel. Look forward to an opportunity to interact with all of you physically or working with all of you. And thanks to Khushbu again for great moderation.
Thank you, sir. Thank you.
Yeah, thank you all. Bye-bye.
Thank you so much. Have a happy weekend.